Hi APES team. In this screencast, we're going to cover sections 4.3 and 4.4. In section 4.3, we're going to talk about how geological processes and climate affect evolution. The outer layer of the Earth is called the crust, and the crust is broken up into large pieces of Earth called tectonic plates. Over time, these plates have shifted, and as a result, the oceans and continents have shifted as well. As a result, tectonic plates affect evolution and the location of life on Earth. Two good examples of this are earthquakes and volcanic eruptions. Earthquakes will separate and isolate populations. Volcanic eruptions will destroy habitat. This diagram shows how South America, Africa, Antarctica, India, and Australia once formed one large supercontinent. The organisms that lived on this supercontinent were broken up into smaller populations when the supercontinent broke up into smaller plates that drifted away from one another. This artist rendition shows the effect of a volcanic eruption on the surrounding habitat and nearby life. In 1980, Mount St. Helens in Washington state erupted, and you can see in these photos the effect of that eruption on the surrounding habitat. You may be familiar with Pangaea, the supercontinent that existed about 225 million years ago that broke up and shifted to form the modern continents we have today. Life on Earth has been affected by climate change and catastrophes in its past. Research shows that the Earth has experienced several ice ages, followed by warming periods after them. There's also evidence that the Earth has experienced several collisions between itself and large asteroids. These two things, climate change and catastrophes, have caused extinction, followed by the evolution of new species. This diagram shows what the Earth looked like 18,000 years ago during the last ice age and what it looks like today. You can see that during the last ice age, the Arctic ice cap extended all the way down into the mainland United States. In section 4.4, we will talk about how speciation, extinction, and human activities affect biodiversity. One thing that we see in the fossil record is that environmental change leads to habitat change. Species that live in these habitats have to either adapt, change their behavior, move, or perish. The formation of new species is called speciation and involves the splitting of one species into two or more new species. The first step of this process is called geographic or physical isolation, where a population is broken up into smaller subpopulations separated by some physical barrier, like an ocean, a river, or a mountain range. The second step of speciation is called reproductive isolation. The geographically isolated populations accumulate mutations and other genetic differences due to natural selection. Eventually, these populations can no longer reproduce with one another. A good example of this are the species of salamanders that live around the Central Valley of California. These salamanders were separated by the geography of California, and eventually they could no longer reproduce with one another. This diagram shows the evolution of the Arctic fox and the gray fox. This diagram shows the evolution of the Arctic fox and the gray fox. An ancestral fox population came to North America and separated into a northern population and a southern population. The northern population evolved to live in cold and snow, and that's how we got the Arctic fox. The southern population evolved for more temperate weather, and that's how we got the gray fox. We can predict how many species we can find somewhere using something called the theory of island biogeography. Island biogeography is the study of the relationships and distribution of organisms on an island. The theory of island biogeography says that the number of species on an island is determined by immigration to the island and extinctions on the island. The theory of island biogeography makes a number of predictions. First, it says that closer islands will have more species than farther islands. Islands that are closer to a mainland source of organisms will have more immigration to it than farther islands. The second prediction is that larger islands will have more species than smaller islands. Larger islands can provide more food and habitat and also more variety of food and habitat than smaller islands can. This diagram points out that the theory of island biogeography applies not only to literal islands, but also to other isolated patches of habitat, like mountains, ponds, and small forests. On an island, you often find specialist species. Specialist species are picky species that may only eat one thing or live in one type of place. You find specialist species on islands because these species had to evolve with access to limited resources and as a result are highly adapted to utilizing them. These island species are often threatened by foreign invasive species. These invasive species tend to be generalists that can eat lots of things or live in lots of places, and as a result, they outcompete the specialist species. When there are no longer any living representatives of a species, we call that extinction. Based on the fossil record, we believe that most, if not all species, will eventually become extinct. We're particularly worried about endemic species. These are species that live in one place in the world and nowhere else. Because of their limited range, they are particularly vulnerable to extinction. One example is the ring-tailed lemur shown on the left. It only lives on the island of Madagascar, shown on the right. There are three types of extinction you should be familiar with. There's background extinction, which is the typically low rate of extinction that is always occurring. There's mass extinction. A mass extinction is a significant loss of species or even major groups of species in a short period of time. Somewhere in between those two is mass depletion. During a mass depletion, we experience a higher than normal rate of extinction.